You know, behind every single line of C++ code you've ever written, there's this one incredibly powerful and, let's be honest, kind of mysterious document that's pulling all the strings. It's the International Standard. So what is this thing really, and why is it maybe the most important text in the entire C++ world? Well, let's dive in and decode it.
Okay, so it really all boils down to this one big question, right? How is it possible that you can write some C++ code on your laptop and then have any real confidence that it's going to work on millions of different computers all over the world? You know, different operating systems, different processors. How does that work? The answer, as you probably guessed, is the C++ standard.
But before we get into how the standard creates all this amazing order, let's just take a second and imagine a world without it. I mean, can you picture the absolute chaos that would happen if there wasn't a single set of rules for the language?
I mean, this is exactly the problem we'd be facing. Without a shared rulebook, every single compiler vendor, you're talking Microsoft, Apple, the folks behind GCC and Clang, they'd all just make up their own slightly different version of C++. And your code written for one would be totally broken on another. It would be a complete technological Tower of Babel. Making software that works everywhere? Forget about it. Impossible.
So yeah, to stop that nightmare from happening, the world needed an ultimate authority. And that authority is the C++ standard. You can think of it like a constitution for the entire language.
And here's the official definition. It's the official document that provides an unambiguous and machine-independent definition of the C++ programming language. Now, this isn't just some style guide or a list of suggestions. No. This is the definitive, binding contract between you, the programmer, and the compiler. It tells compiler makers exactly how the language has to behave, and it tells us programmers exactly what we can count on. It's the universal rulebook everybody agrees to play by.
And this isn't some abstract, mythical scroll locked away in a vault. It's a real thing. This number right here, N4928, that's the working draft for the C++23 standard. It's a PDF, nearly 2,000 pages long, that you can actually go download and read. This is the source of truth. Okay, so what's actually inside this massive document? Let's start with the absolute fundamentals, the rules that make C++, well, C++.
All right, here's a fun little piece of trivia for you, pulled straight from the standard. Did you have any idea that you can write the word "and" instead of the double ampersand? Or not EQ instead of the exclamation mark equals? It's true. The standard explicitly defines these alternate spellings. It's kind of quirky, sure, but it just goes to show you the insane level of detail this document gets into.
And that precision goes way beyond just keywords. I mean, the standard defines every single piece of syntax, right down to how we handle text. Take a look at this table. It shows the official prefixes for character literals, spelling out exactly how to represent everything from plain old text to 32-bit Unicode characters. It's this level of detail that makes it possible for C++ to be a truly global language.
And this right here brilliantly shows just how deep those rules go. This bizarre-looking line of code is 100% valid, legal C++. It's what's called a raw string literal. And the only reason it works is because some section of the standard, I think it's 5.135, meticulously lays out these super complex rules for custom delimiters. This proves a really important point. If it's in the standard, it's legal C++ no matter how strange it looks to us.
But hey, the standard is so much more than just a rulebook for grammar. It also hands every single one of us C++ programmers a massive, powerful toolbox ready to use right out of the box. Just look at this list, and believe me, this is just a tiny, tiny fraction of what's available. The standard library gives us everything from fundamental data structures like vectors and maps to amazing tools for multi-threading, messing with the file system, handling time, all of it. When you install a C++ compiler, you get all of this stuff guaranteed. Why? Because the standard says it has to be there. Okay, so we've seen the rules, we've seen the tools. But now for the dramatic part. What happens when you break the rules? This is where we run into one of the most famous and maybe most feared concepts in all of C++, undefined behavior. Here it is, the official definition, straight from the standard. And it's chillingly simple. Behavior for which this document imposes no requirements. Let that sink in. When your code triggers undefined behavior, you have stepped outside the protection of the standard. The contract is broken, and the compiler is no longer required to do, well, anything predictable at all. This quote from an explanatory note in the standard is so important. Permissible, undefined behavior ranges from ignoring the situation completely with unpredictable results to terminating a translation or execution. Unpredictable results can mean literally anything. Your program might crash. You might silently corrupt all your data. It might seem to work perfectly for years and then suddenly fail in the most spectacular way. It might even, as the old joke goes, make demons fly out of your nose. The point is, anything is on the table.
And here's a perfect example of how sneaky this can be. I mean, this line of code, unsigned char x equals x, it looks innocent, right? Maybe a bit useless, but harmless. Nope. It's actually really dangerous. The standard says that when you're initializing x with itself, the x on the right side is being accessed before its lifetime has officially begun. It's not fully constructed yet, and that, my friends, is undefined behavior.
So this comparison really says it all. When you stay within the rules, when you follow the standard, your code has defined behavior. It's predictable, it's safe, it's portable. It's like you're walking on a solid foundation. But the second you step outside those rules, that foundation just disappears. You're in the world of undefined behavior, where all bets are off. So following the standard isn't just good practice, it's the only way to actually guarantee your code is correct.
So, the C++ standard is the ultimate authority, right? It's the foundation that trillions of dollars of software has been built on. It brings order from chaos, it gives us a universal toolbox, and it defines the very boundaries of what is and isn't C++. But that leaves us with one last really fascinating question. If this document is the law, who writes it?